What my task today is to point out certain things that you need to ask yourself as you're beginning to design and setting up a plan for your car. That's crucial. That's really important. Things that you need to be thinking about. So, let's see. You need to be thinking about materials, roll bar and crush zones, suspension, wheels and brakes. So let's start off with materials. One, you've got to decide what kind of material you're going to build your car out of. Are you going to use steel? Are you going to use aluminum or chromoly? Are you going to use some kind of epoxy material? But if you use steel, then it's not a bad thing. It's really easy to work with, inexpensive, can be a little heavy, but you can, because of its strength, use thin steel, easily changed and modified, readily accessible. And the thing I like about it is that much steel products can be found in squares tubing rather than round tubing. That means new teams who are putting a car together with square tubes, much easier to weld it together than having to do the little grooves that you need if you have round tubing that you get many times with aluminum. So, are you going to choose carbon steel? Are you going to use chromoly, which is more expensive? It's lightweight, easily changed and modified, comes in a variety of materials. You talk to some of the experienced, long-time, old teams, they will eventually migrate to chromoly because of the opportunities it provides, but it can be expensive. But maybe you can provide someone in the community with enough information about your team that they'll come on as a sponsor. How about aluminum? It's stiff for its weight, harder to weld, generally tubular, and you have the notching issue. It resists fatigue, but sometimes you have problems. I remember we were doing a race across Australia. We had one of our tubes break, and we do the normal thing. What does any solar car team do when you've got a problem? Pull out the duct tape and the zip ties. So we put a split around it using other pieces of aluminum, and we zip tied it and we duct taped everything, and it worked better than any other part of the car. So never forget that, zip ties and duct tape. But you can see what you can come up with an aluminum vehicle here. How about you're using a material such as a carbon fiber? I don't so much recommend this for first-year teams because you've got so many other things to worry about rather than how to do the process for a carbon fiber team. But after you've done it for a little bit, many teams will migrate into using this type of material for a monocoque, a single idea frame here. Once you've built this carbon fiber frame, it's very hard to modify. Now, if you use aluminum or steel or chromoly, if something goes wrong, you cut, paste, put it, and you fix it. Here, once you've done this, it's very hard to fix it because of the nature of the material you're working with. Needs careful planning. Sometimes it needs a very intense learning curve, and I bet you, if you play your cards right, if you have questions on this, you talk to Joel Pitts when you're over there at the workshop he's going to do on November 4th. I bet he might share with you some of the fun he's had doing this. So, very interesting. Very hard to repair, though, needs professional engineering, and this is important. If you build something and you say, well, I'm going to use this for my roll bar, I'm going to use this for my roll cage, or whatever it is, you're going to have to get a certified engineer sign off, written, sent to me saying what you have done equals the strength capabilities if you were using steel or aluminum or chromoly because of the nature of what you're dealing with here. That's important there. What about your roll bar and your crush zones? Now we talk about it as a safety cell, and that tends to create an idea of what we're really doing here. We're trying to create a safety environment for the driver. And the whole idea is you've got three things that are protecting you. You've got a safety cell that's around you that's made of harder material, tougher steel, tougher aluminum, whatever it is. And that's got to be at least 5 centimeters away from the driver. This is designed to not crush in the event of some kind of collision. Then outside of that, you've got a crush zone. And this is made of lighter weight material designed to give way in the event of some kind of collision. And that's got to have a 15 centimeter clearance from the safety cell to the outside of the car. Safety cell around the driver to the outside of the car. So you've got enough room for things to crash in. Now, we're not saying you're going to have a crash. We don't have so many ideas of crashes. The biggest crash I remember was when a chase car ran into the New York car and crumpled it a little bit, and it was on a cross-country race. But we want to do everything we can possible to make sure you're going to be safe. And some of the original cars that were built for the Solar Car Challenge did have some kind of front protection and rear protection, but there was so much space from the side, we had a running joke that you could drive an 18-wheeler through the side of that solar car and never touch anything except the driver. So what we're doing is trying to provide ways that are intended to protect you. Now, look at what's done here. You've got a really nice little crumple zone here. And look at what they've got here on this team. And look at this particular one too. You've got protections from the shoulder of the driver, for the head, and the roll bar here. Protections for the roll bar, and look at how it's supported from the rear so it's not going to cave in. And this is designed to protect the shoulder. These are great examples of a crush zone, a safety cell, and a roll bar. Roll bars are designed to prevent crushing into the driver in the event of a rollover. We've never had a rollover in 30 years, but we've got to look towards the possibility. The most we ever had was some people had using a bicycle fork for their front wheel suspension. And, you know, that wasn't a really good idea. So the forks gave way and the car rolled on its side on the first turn of the race. So, no, we didn't have a rollover. We just had a sort of a baby buggy carriage collapse, and it just... But anyway, those are the things you need to be thinking about as you start designing a car. We need a rigid safety cell, we need a crush zone, and we need a roll bar. And that roll bar needs to be welded out of one piece of material and welded twice to the frame here, welded twice to the frame on the other side. And we like the back support here, or here they've got it in the front, and that protects the driver's arm and shoulder there. That's important. Okay, here's some other examples of a roll bar. And notice this. Here you've got your driver. There's got to be a 5 centimeter clearance between the top of the driver and the roll bar. Because if you do roll over and it caves in a little bit, we don't want it to get in contact with your driver there. And this is tested for every driver you're going to have. You don't get the little short driver like me sitting in there and trying to qualify. You want to have every driver qualify. And this was pointing out the significance of that continuous piece of metal. You think about that in your planning, particularly if you don't have a shop. Where are you going to go to get somebody to bend that material for you? Because a roll bar has to be a certain strength, and that's set out in the rules pretty specifically. So part of this is you're being involved with your community enough to find a metal shop that will bend that piece of material for you. Crush zone must be designed to absorb an impact. 15 centimeter horizontal distance from your safety cell. I think I've already said that pretty much. Here's a nice diagram we have in the rules that shows what we're trying to do to protect. Here's the protection here for the driver's body. The torso here is for the legs and feet down here. And from the ground up to here needs to be 30 centimeters. That's so that if something came to hit you from the side, it's not going to go over and above and hit the driver. This is a good example of it. This is what you don't do. Notice here, there should be 5 centimeters between the driver and his safety cell. Notice they build the crush zone using the same material as they build a car. So this is sort of an example of what not to do. Okay, let's look at suspension and steering. Common types of suspension, you've got your McPherson strut, your solid axle, Your dual A-arm, which seems to be the favorite of most solar car teams because it seems to work really well with your steering. Our first car didn't have any kind of suspension on it. And it worked. It was flexible steel, and we just sort of flapped around and did okay, and it was a closed track event. By the time we got to the end of the race, though, the car had so torqued from the forces that were on it that we really had to discard it. But it lasted for one race. So, if you're thinking on a bare minimum, then you don't think about it. But when you're talking about solar cells made of glass, if you don't have suspension on it, then you're really asking for lots of damage and expense and replacement of cells. So the best way to go, and for some kind of condition for your driver by the time it's over with, think about putting in a suspension. And as you do, you need to be thinking about how you're going to handle your steering. We do extensive work about this and steering, and that young man will do this, I hope, in January, talking with you about how you handle your steering and alignment, because you've got certain things to consider. This is ideal, the way that the car should look from the side. The tire inflated enough that you only have this little bit of patch on the ground because of rolling resistance. But in actuality, what you generally have is less deflated tires. This is going to be what you've got on the ground, and that's creating more resistance. It makes it harder. You're using more energy to get down the road. What about wheels and brakes? You were talking about the different types of things that you can get with different wheels and brakes, but this is difficult in your first decisions you have to make about your car. When you're making that first plan, your first design, you've got to decide, am I going to build a 3-wheel vehicle or am I going to build a 4-wheel vehicle? And by the way, as you're doing your planning and designing, go into it that you're going to put enough effort to make good decisions so that you don't have to go back and change things a month later. That's hugely destructive to programs. Make good decisions and stick with it. If you decide you don't like what you're doing, we'll revise for next year. But make your decisions and carry through with them so that you can have a progress, not go forward and back a month and go forward and back a month. But this is one of those decisions that's really going to change what's going on. If you have a 3-wheel design, yeah, it's lighter. It's easier to align because you're only having to align these 2 wheels right here. Less expensive because you only have 3 wheels, not 4. But it's not as safe. If you have a wheel go out on you, or if you have a flat tire, then you don't have that much holding you up. I always believed in 4-wheel designs. The idea being in a 4-wheel design is if you've got one tire go flat or go out on you, then your car is probably going to still stay up. And this happened to us. We're going out to Australia. We're going like 45, 50 miles an hour down the road, and we lost one of our front wheels. And we were able to maintain control and not a problem. We also had a time when we were driving along, and the driver radios to me and he says, "Doc, is anybody else driving with us?" And I said, "Why?" And he said, "Because I just saw a wheel pass me." And I said, "Yeah, it's one of your back wheels." So, if you've got a 4-wheel, you've got a little forgiveness in there. There's another factor. If you have 4 wheels and there's a dead skunk in the road, you can go over that skunk. But if you've got 3 wheels, one of your wheels is going to catch that skunk. And let me tell you, how long skunk smell stays in that solar car for the entire time you're doing it is amazing. So that's something to consider. So think about that as you're choosing what you're going to do. Some people say, well, when I use 3 wheels, then I don't have to worry about the back here and some kind of transmission because of 2 wheels, and you're only powering one of the wheels. You're not powering both wheels. So one wheel's free to turn at a different rate. And we found it was minimized when we brought those 2 back wheels closer together. So it sort of simulated one wheel, but there were two wheels there in the tire. So think about this. Your wheels are an important decision that you're going to make. Here's an example of a 4-wheel car. more parts, harder to get an alignment because you're aligning both these wheels and these wheels. Why is that important to align? Because it relates to wear and tear on your car. We were using some expensive wheels that MIT had built. We were using a famous tire that cost like $97 a tire. And we entered one of the Winston races, and in the first period, the first 3 hours, we lost either 11 or 14 flat tires because we couldn't get the car aligned. But I promise you, during that lunch break, they learned how to align the wheels. So the alignment's going to determine lots of good wear and tear better on your car. Better weight distribution with four, much safer, can straddle dead animals. Okay. And four wheels are required for a cruise division. Different type of wheels you use. This was that famous NGM wheel made from MIT. And notice it was a piece of aluminum, totally milled out. You've got a solid wheel. It's totally going to support both vertical and horizontal stresses on there. Don't use a bicycle wheel because it wasn't intended for this kind of thing. Bicycle wheels are intended with forces in a vertical line. It wasn't intended for lateral forces on it. And here's what happens. You go around a turn at decent speed and you put stresses on the spokes. The spokes get loose because they're not welded in, and they actually will poke a hole in the tire and you get a flat. So if you are going to do this, do something like put a piece of metal and take out the spokes on that bicycle tire and use an aluminum piece in the middle, or weld in your spokes so that they're not going to get loose. But bicycle tires, wheels, not as good as some others. But then the bigger the wheel you've got, the more weight, and you've got to decide that as you're going down the road. On a closed track, a heavier car is not as much of a problem because once you get going, you've got your momentum there, and that's going to carry you forward, and the extra rate's not necessarily a bad thing. But if you're going cross-country, then that extra rate will kill you because it's all start, stop, start, stop, start, stop. And every time you stop, then you have to use an excessive amount of energy to get the car going again till you get to the next traffic light where you stop. And then you have to use it again. So heavier, okay, maybe on a closed track for next year. Cross-country, it's not so much. And by the way, I'm giving you a challenge. We are doing a cross-country in 2025. And that cross-country is going to be around the state of Texas. You're going to get a chance to see the trees in Palestine and Texas and the Big Bend and up to Palo Duro Canyon and see some really great things. So if you haven't seen Texas before and seen all the different landscapes, you'll get a chance to do that. We're going to go through lots of little towns and have a marvelous experience, and it's going to be about 1,800 miles offering. So it will be an interesting experience for you. But if you're from Texas, you'll always be close enough that you can get home at night if you wanted to. So. Anyway, just telling you what's ahead. Here's some example wheels. This wheel right here is interesting because this thing's not going to crater in, but look at the spokes that they've got here. Is this going to hold up? This one's going to hold up because it's got nice supports here. When we talk about brakes, solar cars must have two independent braking systems that allow the driver to stop the vehicle and safely and quick with just one of them. You've got one to use and one for backup, or use them both at the same time. Most will use hydraulic disc brakes. Then you have to learn how to bleed the brake system. And you have to learn to wear a mask when you're bleeding the brake system so it won't splash on you. But these are pretty interesting stuff. One of the best parts about the braking is two separate systems. You have two pedals on the floor. No hand brakes. Gotta be two pedals on the floor. No linkage between the pedals. And all of this is because of something that happened to more than one solar car, but let me tell you my experience. We were doing a race in New York City, and we were in Battery Park, and the driver said, we want you to go as fast as you can through Battery Park and hit that brake, and we want to see that it'll hold okay. So my driver's driving, and we were up to about 40 miles an hour, and he hits the brake, and the well that's holding the brake caliper onto there gave way and it goes flying past the driver's head out through the front windshield of the car. So now we have a car traveling 40 miles per hour through Battery Park in downtown New York. And I've got 14 kids running after that car. So knowing that we're building this, I realize there is an essential point to have a dual system here. So you've got two braking systems, two independent braking systems. So that's where that came from. Brake testing, we have two types of tests, static brake testing, dynamic. Static means we'll sit there and you've got your foot on the brakes and we'll see if we can push your car, see if it give way with static pushing. And then dynamic, you'll have to drive as fast as you can and see how quickly you can come to a stop. The rules set up a guideline for you. You have to know if you reach a certain amount of speed, 20 miles an hour, wasn't it, Christy? Do you remember on that? Did you do braking? It was 20. Okay. Oh, yeah, okay. Then you had to be able to stop in a certain amount of time.
25 seconds.
Okay. Thank you. Thank you. You see, that's where we go for good resources, our volunteer back there. But also then we take you out on the track and we say travel as fast as you can, hit the brake. We want to make sure your car doesn't fishtail. Because if you fishtail, you could hit another car that's traveling on the track with you during a race. We want to make sure your braking system is balanced and controllable. So that's an important thing for you. And that's mechanical for us right now. Now, during our January workshop, we'll do a greater in-depth mechanical discussion, and I'm always available for any kind of questions you want to email to me. Anybody have any questions you want to ask now?